An active surf resort is a logistical collision. At any given moment, you have drivers navigating traffic to pick up arrivals, while kitchens are prepping hundreds of specific meals, and instructors are moving groups of surfers depending on the tide. Standard property management systems aren't built to handle this physical coordination. They're designed almost entirely around static room allocation and standard CRUD operations, checking guests in and out of a grid. The surf resort domain requires dynamic logic. You need automated airport routing mapped to flight times, session planning dictated by real-time coastal weather, and kitchen dashboards that filter daily covers by dietary restrictions, like vegan or gluten-free. WavePMS is a B2B SaaS platform engineered specifically to digitize these edge cases. It replaces manual spreadsheets with dedicated, interconnected modules for every department. Building a platform like this introduces a massive engineering constraint: securely hosting thousands of competing global camps on a single unified codebase. Every single property requires absolute data isolation. You cannot risk a guest list from one camp leaking to a competitor, and you have to maintain that strict separation while processing a huge volume of highly concurrent, real-time requests. We're going to deconstruct the WavePMS version 2.0 stack. We'll look at how it solves this using a Postgres multi-schema architecture, paired with an event-driven, role-based access control layer. Handling hyper-specialized operational logistics requires moving away from standard CRUD structures and instead building strictly isolated real-time ecosystems. The bedrock of this isolation strategy sits at the database layer, running Postgres 15. Traditional SaaS places Camp A and B data in one table, relying on a simple tenant ID. But one missed where clause causes catastrophic data bleed. To prevent this, WavePMS leverages PostgreSQL's multi-schema architecture, splitting the database into entirely separate, walled-off schemas. This separation creates a challenge for Laravel 11. The application must dynamically route traffic to the correct schema for every web request. An incoming request hits the Laravel application gateway, where the tenant resolver middleware sits. It extracts the custom subdomain, identifying the specific client, and locks the database connection strictly to that tenant's Postgres schema. The backend is now completely blind to any other schema. Developers deploy updates to a single unified codebase, knowing it safely applies across all isolated tenants at scale. A multi-schema architecture effectively eliminates application layer data bleed while maintaining the operational and deployment efficiency of centralized SaaS. Once a tenant schema is initialized and secured, the focus shifts to the specific data models populated inside it. In this entity relationship diagram, the primary anchor is the reservations table. It maps directly to a meal plans table, which calculates daily covers and filters them by dietary requirements, like vegan or gluten-free. Additional branches connect to dedicated tables for shuttles and surf lessons. These peripheral tables accept dynamic inputs from third-party APIs. For instance, the surf lessons table cross-references schedules with real-time conditions pulled from the Open Weather API. A single booking at the reception desk ripples out to the chef, updates the driver, and alerts the instructor. Rigorous entity relationship modeling takes chaotic, cross-departmental human communication and converts it into predictable, automated data pipelines. With these pipelines active, the system must grant staff members access to their specific modules without ever exposing sensitive financial or administrative data. This matrice roles and permissions table governs strict access boundaries. Notice the intersection of the driver column and the flight delay alerts row for exclusive access. In contrast, the surf instructor has read-only access to schedules, but write access to daily attendance lists. This matrix is powered by Laravel Sanctum. Upon login, Sanctum generates a scoped JSON Web Token, or JWT, encoding their exact permissions. On the server side, these scopes translate into strictly enforced API middleware. The server instantly drops any request lacking the proper JWT authorization. On the client side, the Vue.js frontend reads these JWT scopes to conditionally render components. Without financial access, the billing UI never loads. To further harden accounts with high-level access, like the superadmin or manager, the system integrates optional two-factor authentication. This matrix functions as a strict mathematical boundary, governing every API endpoint and client-side state change across the tenant environment. Static access permissions secure the data, but the platform also has to manage asynchronous, real-time operations. If an external service detects a sudden flight delay, the system must process that alert instantly without blocking the main PHP thread. This sequence diagram starts with a JSON payload from an aviation API. It hits a Laravel webhook and is instantly offloaded into a Redis memory queue. A background Horizon worker processes the job asynchronously, and a Sockety WebSocket server broadcasts the alert to authorized clients. For the end user, the experience is immediate. A driver navigating traffic receives a flashing alert on their dashboard device the second a flight status changes. Pairing Redis background queues with WebSocket push architecture ensures high-latency external dependencies never bottleneck local system performance. Deploying, monitoring, and scaling RIS system internationally requires a robust macro infrastructure. This map outlines the deployment flow. Code updates trigger GitHub Actions, which build Docker containers and push them directly into a Kubernetes cluster. The system is fronted by Cloudflare Enterprise for CDN caching and DDoS protection. As traffic spikes, the orchestration layer dynamically spins up horizontal Laravel worker nodes to absorb the load. As a failsafe for global scale, the architecture allows for regional Postgres database sharding, separating European data clusters from Asian ones once the system exceeds 1,000 isolated tenant schemas. What starts as rigid, isolated data schemas on a single server scales into a fluid, real-time application ecosystem distributed across multiple regions. The WavePMS stack demonstrates that managing specialized domain requirements, from dietary restrictions to airport logistics, requires a precise alignment of isolated data schemas and event-driven processing.